1.4, subtraction, which is difference. It's also considered distance, by the way. So if we said, what's the difference between numbers? That's just the straight difference here. You'd say, what's the difference between two numbers? That means you're subtracting the two numbers. But again, it's the same thing as saying, what's the distance between two values? Well, then you're using subtraction. And yes, this is the symbol for subtraction. It's just this a little horizontal line right here. And it would be between two numbers, like, I don't know, 5 and 4, right? 5 minus 4. So subtraction, yeah, sometimes it's called minus. Not Midas, but minus. So you'd say this one could be pronounced as 5 minus 4. 4 take away from 5. 4 subtracted from 5. 5 subtract 4. There's lots of different ways to verbally demonstrate subtraction, but it should come out the same way when we use the symbols in mathematics like this. So subtraction. Subtraction is the same as removing, taking away, losing, or spending. I prefer to think in terms of spending. I like money. I like money a lot, actually. Not that I have a lot of it, but spending, right? If I start thinking about, if I subtracting in terms of spending, then if I looked at that same problem, 5 minus 4, okay, it would be like saying you have $5 and then spend $4. How much money do you have left? And I'd know pretty quick that that's you'd have $1 left over right there. Okay. Now, whether you use money or fingers is up to you. Fingers, again, they're the most convenient concrete object that we have to use addition or subtraction. And so this first example we're going to show with fingers. So yeah, even though my drawings aren't great, let's try this one out. So this is what the first number in the subtraction problem is, the number that we start with, right? So I'd say that's our starting value. So in other words, I'm going to start with 5 fingers up, right? So I got 1, 2, 3, 4, 5. There's 5 fingers. Now this is minus 1, so I'm going to take away 1 finger, right? That sounds kind of morbid, but I'm going to take away this 1 finger, which means I'm just going to put it down, okay? I put down the pinky. I know some of you guys would like to see me take away the thumb. Okay, that's fine. It's still the same number. You still end up with 4 fingers up, right? So that's what our answer is, 4 right there. Now, this next problem, I'm actually going to change this one a little bit. I don't want to see anything as big as 67 just yet. We'll look at other problems that have bigger numbers like this. But I just want to look at 7 minus 4, right? Because we're using more concrete examples. And yet, you get to the point where using fingers really may not be the best way to do it. Best meaning maybe the fastest, right? But when we're dealing with smaller numbers like this, it's extraordinarily convenient just to have fingers. And you'd say, well, I got 7 fingers up, 1, 2, 3, 4, 5, and then 6, 7. That's how much I start with. And then I'm going to take away these 4 fingers, right? So I'm going to put this one down, 1, 2, 3, 4. And how many fingers do I have up now? It's 3 right there, okay? Now, as we look at bigger values, we're just going to be working within the place values. So if we can get just single-digit subtraction down, then hopefully we'll understand it better and be able to do it better. But there's a point which, and I know some of you guys are expecting this to happen, we're going to be needing some borrowing, all right? We shouldn't need it now. We're not going to need borrowing now, but we may need it. We are going to need it in the future, okay? Now, in the meantime, it'd be nice if everyone could memorize at least these subtraction facts. Right? If you're just taking one digit and subtracting a smaller digit, then you can perform calculations with speed and ease, right? Like, for example, if I said 1 minus 1 is 0, hopefully you wouldn't have to use fingers to do that, right? Now, if you do, don't feel ashamed. That's not what I'm saying here. What I am saying is if you can memorize this stuff, then performing these calculations is just faster, it's just easier. Now, something you'll want to notice is as we take away more, the total goes down more as we go, right? So like this one, 9 minus 0 is 9. 9 minus another 1 is 8. 9 minus another 1 is 7, right? So 9 minus 2 is, see how we're taking away 1 more each time, which is taking away 1 more each time from the total or the difference. The other thing that I want to point out here with these subtraction facts is when you take something and subtract it from itself, you get 0, right? That's going to be one of our properties that we're going to see in 1.5. So keep that in mind, and it's important to know this is that something subtracted from itself. That's one of the crucial properties that we use in algebra. And I know we're still focusing on arithmetic, so don't worry about the algebra now. But just understand that if you can get that down, anything subtracted from itself is 0. It's going to open up a lot more doors to you in mathematics. All right, so let's do this subtraction. And again, I would say I got this stuff memorized, so I know 7 minus 3. Again, yeah, you could find it in the table if you needed it, but that's the point of memorizing. You wouldn't need this in front of you. So yeah, 7 minus 3 is 4. Or I could say 6 minus 4. Well, I would know that if I had this memorized, that 6 minus 4 is 2 from that subtraction fact, okay? Now, could you use fingers? You could, and you'd be fine, all right? Now, once we know those basic subtraction facts, we can subtract any size number. Now, yeah, again, there's going to be a point where we need to borrow, and that's okay. But if we can focus on those numbers, really, like if you could memorize like from 18 minus 9 down to 0 minus 0, like we saw in the subtraction fact family stuff, then you'd be really well off. Okay, but yeah, we need to be able to subtract from 2-digit numbers as well, which we will see. Maybe I should show an example of that, right? So let's say I did 13 minus, I don't know, 7, okay? So if I were to do this with my fingers, here's what I would do. I'd put 3 fingers up. Now, why am I only putting 3 fingers up instead of 13? I don't have 13 fingers, I'm sorry. If you do, then more power to you, okay? But 13 is going to be represented by these 3. I just know I got another 10 fingers to work with, right? So I'd say minus 7. So I'd say, okay, put down 1, 2, 3 fingers. So that's 3. I need to get to 7, though. So then that would give me 10 fingers up now that I use the 3 from the 13. And then I've got to take away another 4 to make 7, right? So I counted 3. So there's 4, 5, 6, 7. And how many fingers do I have up now? 6. So if you're using your fingers to make this subtraction, that's fine. It's okay. It's good. If you need to use your fingers for all the calculations instead of memorizing, that's okay. It's not a problem. All right, so now subtracting with values 10 or higher. And again, this is the beauty of the place value system, is that we only focus on one place value at a time unless we need to borrow, which we'll get into. But something else you need to understand from this is when numbers are big, specifically, it's nice to stack these just like we did with addition problems. So we're stacking these by place values, right? You got a 2 in the thousands, 6 in the hundreds, 4 in the tens, 7 in the ones. Thousands, hundreds, tens, ones. Minus 531, 5 in the hundreds, 3 in the tens, 1 in the ones. So hundreds, tens, ones right there. The other thing that is important is to understand that order is going to matter with subtraction. So when I stack these, the first number farthest to the left should be on the top, and the second number here is on the bottom of the stacking, right? So when I look at these, it's by place value. I'd say, okay, I'd focus on the 1, 7, spend 1, you'd have 6, 4 spend 3, 6 spend 5, and then the 2 was just the 2 right there, okay? And we'll be doing problems like this. But yeah, start with the place value farthest to the right and then move to the left, which is going to allow us to use borrowing if it's necessary. Now, for us, the place value farthest to the right should be the ones place value. I don't think we get into decimals in this class, but if you ever do get into decimals, yeah, it is possible to go into decimal values. But right now, we're not worried about that stuff. All right, so we got our subtraction facts down there. Whether you got them memorized or not, doesn't matter. Let's write these problems out. So again, I got 85. If I stack these for subtraction, that would be my top number. And yes, I am putting some space between the 8 and 5 on purpose, just so I know I am working with individual place values one at a time. Then I'm going to subtract, so I'm going to show the subtraction symbol. And there is some need for the subtraction symbol, of course, because as we start to add other operations, like we've already done addition, now subtraction, There are other operations which we will see, so it's important to specify what operation we're using, which in this case is subtraction. Well, I'm subtracting 42. That's a 4 in the tens place, a 2 in the ones place. So I line the 4 up with the 8 in the tens place value, the 2 with the 5 in the ones place value, and we subtract. Now, just like we did with addition, like we explained on that last slide, we're going to focus on one place value at a time. So I'm going to ignore the tens place value right there, right? So I got 5 minus 2 right here. So again, whether you're using fingers or not, it's up to you, but I'd have 5 fingers up. Subtract 2 means that I'm going to put 2 fingers down, and I got 3 fingers up right there, okay? So that's the ones place value. Now I focus on the tens place value, which is 8 minus 4. So, however you put up 8 fingers is up to you. 1, 2, 3, and then subtract 4 fingers. There's 1, 2, 3, 4 right there. So that's 4 fingers up, and that result is 4. 8 minus 4 is 4. So what's our final difference? Again, difference is the final answer for a subtraction problem. 43. 85, take away 42 is 43. So we'll do the same thing on the next problem. 67 minus 11. And again, if you don't feel like there's enough space between the place values, feel free to separate them a little bit more. I wouldn't separate them too far just because it's easy to get that stuff mixed up, right? So 6 in the tens, 7 in the ones, that's 67. 11 is 10 in the ones, 1 in the tens, and then 1 in the ones place value as well. But again, we're going to focus on one place value at a time. So I'd say 7 minus 1. Again, whether you use fingers or not, 7 fingers up, 1 finger down, that's 6 fingers up now. That's the ones place value. Now the tens place value, 6 minus 1, 6 fingers up, 1 finger down, and I got 5 fingers up still. All right, so what's our final result? Our difference, 56. Now, whether you're using fingers or like if some students actually have had, pennies or some kind of form of money that they can afford, generally that's pennies, right? Whether you're using that method or whatever method you got, or if you've got this stuff memorized, it's all good. As long as you're doing the right calculations, and we're in good shape. So this leads us to borrowing, though. So when we're taking away too much, meaning that second value, if it's too much, then we have to borrow from the next place value, okay? And again, maybe I'm relating this too much to money. But again, I like to think about it in terms of money. I don't know why, but my brain just clicks that way. So it's like saying a $100 bill, right? You can split it up into smaller denominations, such as tens and ones, right? So you could say a $100 bill, it has the same value as 9 $10 bills and 10 $1 bills, right? If you added these two total of bills together, you'd have $100, okay? So again, this example right here is like saying you go into the store with $100, and yeah, I don't know a lot of people that walk around with a C note in their pocket, but let's say this person does. So you got $100, you're gonna take away $7, right? So you just spent $7, and so if you're the cashier, you got, okay, well, what am I gonna do? You got to figure out how much money to give this person back. Well, what would you do? You'd say, let's say you only got tens and ones, of course, to make this convenient. So you'd say you get 9 tens back and 3 ones back, right? And again, these other 7 ones combined would have given us 100. That's going to give us a fact family, which we'll talk about in the next lesson. But for now, just understand that what happened is really the cashier took the $100 and they split it up into 9 tens, which is $90, and also 10 ones, which is another $10, which combined would have given us $100. And that's how we're able to borrow between place values like this. And I'm going to be showing the work on this borrowing stuff in this way so that you understand where the borrowing is coming from, so that you don't have to worry about, there's a 0 here, so I don't know how to borrow there. We're going to go over problems like that, okay? So again, whether you got the subtraction facts memorized or not, with borrowing sometimes you won't necessarily be using these specific subtraction facts. But again, if you have them memorized, if you don't need to borrow, then it'll be extraordinarily convenient. So first up, we got 82 minus 25. So that's an 8 in the tens place value and a 2 in the ones place value, minus 25, that's a 2 in the tens place value, and a 5 in the ones place value. So I need to subtract these. And when we do subtract, just like with addition, we're going to focus on the place value farthest to the right first. So that's my ones place value. But again, I got 2 minus 5. Well, 5 is too big to take away from 2, right? 2 minus 5. And now some of you may be thinking, well, that goes into the negatives. We don't want to worry about negatives right now, okay? We just want to focus on being able to subtract. We'll worry about negatives later. But for now, 2 minus 5 is just not big enough. So that means I need to peek into the tens place value. Now, I'm borrowing specifically for the 2, right? The 2 is not big enough. So I'm looking to its tens place value, which is an 8. There's 8 tens there. Excuse me. Which is 80. And what I'm going to do with that 80, I'll show the work for it, okay? I'm going to take that 80, and I'm going to split it up into 7 tens and 10 ones. All right, so the 7 tens, the 70, is just going to show up as a 7 in the tens place value. All right, and then these 10, I'm going to tag those onto the ones, right? That's not a $10 bill I'm talking about. It's 10 ones, which I can now combine with these other 2 ones, which now makes it 12. See that? Now 12, I have enough to take away the 5. So I'm going to cover that up again so I don't get it mixed. And then I can focus in on this particular part of the problem. 12 minus 5, again, however you use your fingers or whatever you're using to take away 5 here. 12 minus 5, I'm going to use fingers. So I got 2 fingers up. So I'm going to put 5 fingers down. 1, 2, 10 fingers up. 3, 4, 5. I got 7 right there. 12 minus 5 is 7. That's the ones place value. Now let's go to the tens place value. And again, it's not an 8 in the tens place value right here. It's a 7. So in the past, what I've seen students do is they just completely just scribble over that 8 right there so that it's out of their mind. They don't have to worry about it. They don't have to think about it. Now they know it's 7 minus 2 in the tens place value. It's really 70 minus 20, what we end up with right here. 7 minus 2, so 7 fingers up, 2 fingers down, it's 5. Okay, now there's no other place values to work with, so we're just looking at that. 57 now, which is our difference. It is the difference between 82 and 25. We got 18,532 minus 5,786. But remember, and this is important to remember because sometimes we get discouraged when we see big problems like this. It's not like it's changing the work. It's just changing the amount of work, right? So I don't, in my own opinion, I don't think that it makes it more difficult. It just makes it more, right? More work. So whether it's more work or less work, the process is still the same. So it's just work. So this one comes out 18,532, right? So 1 in the 10,000s, 8 in the thousands, 5 in the hundreds, 3 in the tens, 2 in the ones place value, and we are subtracting 5,786. So that's a 5 in the thousands, 7 in the hundreds, 8 in the tens, and a 6 in the ones place value. So that sets up our problem like we need it to. That's good. But just like we did on that last problem, whoops. I'll just make a new one. Oh, well, I did not expect that to happen. Here we go. There we go. That'll cover them up. So I'm focusing on my place value farthest to the right, which is 2 minus 6. But again, 6 is too big to take away from 2. So I need to increase the value of the 2. And again, this is the beauty of our number system, is we can borrow from other place values, but in addition to that, it's not like I'm going to make that 2 a 5 suddenly. It's just going to become added with some kind of base 10 value, like in this case 10, right? Which would make it then 12. So I got a 2. I need to borrow from my next place value. That's the tens place value. So I look at that 3 and the tens place value. Again, there is the 8 here, but I'm not worried about that 8 because I'm not borrowing from this 8. I'm borrowing from the 3. So I say, okay, 2, I need to borrow some from that 30 right there, right? So I look at the 30, and I'm going to split it up. I'm going to make it 2 tens, that's 20, and then 10 ones. That is a total of 30, right? 20 and 10. So the 3 then now becomes a 2 from this 20 right here. And this 10, I'm going to put into the ones to make that a 12. All right, so I've borrowed from the tens place value. So let's go back and cover up the tens place value because now I have a big enough number in the ones place value to take away 6. So 2 fingers up to represent 12. I'm going to take 6 away. 1, 2, 3, 4, 5, 6. And I get 6 fingers up. So 12 minus 6 is 6. Now we go, because that completes the ones place value. Let's go to the tens place value. Well, it's not 3 minus 8 anymore. It's 2 minus 8. And again, whether you scribble that out completely or just simply cross it out like I had before is up to you. Whichever, again, helps you to think more clearly and focused on the values that we actually are working with. So this is 2 minus 8. But again, 8 is bigger than 2. We can't take away 8 from 2. I need to borrow from my next place value. So I go to the hundreds place value, right? I feel like I need a little bit more space here. I'm going to get rid of some of that subtraction fact stuff. Okay, so the 2, again, that's 2 tens, by the way. And I'm going to make it 12 tens instead by borrowing from the 5. So again, just so you understand what is happening, that 5 in the hundreds place value is 500. But I'm going to split it up and make it 400s, which is 400. And then I need some tens, right? Specifically 10 tens, which is 100. And yeah, I'm just going to take this 400. It's going to stay in the hundreds place value as a 4. Right there, that green 4. But this 100 right here, that's tens. So that's 10 of the tens, which makes 12 tens with the 2 that was already there. So now that I've borrowed, hopefully well, then I can take 12 minus 8 here. 12 minus 8, so I got 2 fingers up. I'm going to take 8 away. 1, 2, 3, 4, 5, 6, 7, 8. I got 4 fingers up, so that 12 minus 8 is 4. Then I go to the place value I just borrowed from, the hundreds place value. And again, the 4 is too small. I can't take away 7 from 4s because the 4 is not big enough. So I need to look to my next place value, the thousands place value. And I need to borrow 1,000. So I'm going to borrow 1,000 from the 8, which makes that 1,400 now. So that's one of the 8. And so what happened? Well, I decreased the 8 by 1 to make that 7. And again, just what I have in blue there with the 7 and the 1, that's 7,000 and 1,000 right there, which gives us the original 8,000 that we had to start with there. All right, so now that I've borrowed, I can go to my place value, the hundreds, and I've got 14 minus 7. So 4 fingers up, take away 7. 1, 2, 3, 4, 5, 6, 7. Yeah, 7. Thought I miscounted that, but yeah, that should be good. 7. So that's from 14 minus 7. Now the thousands place value, 7 minus 5. So 7 fingers up, 5 fingers down, boom, 2. Right there. So that's a 2 in the thousands place value. And then we're on our 10,000s place value, which is just 1. Now, however you say this or do it, we're just really dropping that 1. I like to show the arrow just so I know where that 1 came from because I'm not actually operating with it So our final result here, the difference between 18,532 and 5,786 is 12,746. Now, please understand, this borrowing stuff is serious business. This is usually where we end up with a lot of questions. Because borrowing, it's not direct, right? Like we have to look into other place values to borrow from. Now, you may think, well, it's kind of like carrying. It kind of is. It's just the reverse of it, right? Which is where we kind of run into problems. Like, I find that most students in this class can carry very well. But when it comes to borrowing, that's where we tend to struggle. And by the way, this is where I tend to borrow from a lot. This is where I tend to struggle a lot when I do calculations in my head. Like I can be pretty close, but sometimes I either borrow from the wrong place value or I forget to borrow, which is why, yeah, I'm a lot more accurate when I show my work. Am I completely accurate? No. I mean, I still make mistakes, but I tend to make more mistakes with the borrowing business and even the carrying stuff when I do stuff in my head. So be very careful with this borrowing business. So subtraction and borrowing with zero. That's good. That leads us right into this one. Okay. Now this one shows 501 minus 63. Now what they should say right here is that should show as 11 right there. Now you may be thinking, well, why are you showing two different problems, Sal? I'm not. This is the same problem right here. Well, what the crap happened? Well, it was 501 minus 63, right? 501 minus 63. But, yeah, this is where we come into the borrowing with zeros problem is if you look at the ones place value here, I got 1 minus 3, but the 3 is too big to take away from the 1. So I would have to look into the tens place value. Oh, there's nothing there, right? So right now, this shows 1 minus 63. Well, it's just not big enough. We don't have enough to subtract, okay? So that means as well that I need to go into an even bigger place value, which in this case is the hundreds. So what does that have to do with this garbage right here? Well, here's what we did. Is I took 500, right? And I'm not using the 1 yet. I'm gonna borrow into the 1 here, okay? But the 500, what I got to do to make it borrow into the 1s is I'd have to make it 400, right? And that's where this 4 comes from in the hundreds place value. But then also 9 tens, which is 90, and that's where the 9 comes from there. And also 10 ones, like this. That's where this, let me get rid of that. That's where, what's that? What the heck? There we go. That's where this 1 comes from. That's the 10 right there, okay? And of course the 1 in black, that's just the one that we started with. So 501 is the same as 400 plus 90 plus 10 plus 1. See that? It's just right here, that's what I'm putting in my 1's place value as an 11. Okay? And now, yeah, it did change the 10's place value. Now it's not a 0, it's a 9, right? Because if you look at this as a 2-digit number, it was 50. Now it's 49 because I borrowed 1 from the 50 to make it 49. I don't know if that really helps. I'm just kind of throwing it out there. Maybe I'm fishing a little bit to see what sticks, right? So now that we have this, now we have enough to take away that 3 right there. So yeah, I'd say, oh, okay, what the heck happened? There we go. I'm going to just focus on my 1's place value. That's 11 minus 3. So 1 finger up, 3 fingers down. 1, 2, 3. I got 8. Okay, so we're going to move this over here. Now in the tens place value, we got 9 minus 6, so 9 fingers up, 6 fingers down, and I get 3. Again, that 9 came from what would have been the 50 tens right there. Then I moved it over even more, and in the hundreds place value, we just got a 4. 438. That would be our difference between 501 and 63. In my personal opinion, it's going to take a little bit more experience than one problem to get used to this borrowing from zero business. All right. In fact, I think one of the examples we have to borrow from 2 zeros, which we'll see. So I'm going to do this first one. Okay, it's 60,502 minus 5,786. So let's go and write this out. So 60,502. I'm giving myself some space between the place values there. Each digit in its own place value, and then 5,786. 5 in the thousands, 7 in the hundreds, 8 in the tens, 6 in the ones. And we're going to subtract. And when we do subtract, it's nice to focus on one place value at a time. So I'm going to focus on the ones. But, just like we've seen before, 2 minus 6, the 6 is too big to take away from the 2. So I need to borrow from my tens place value. Oh, there it is. See that? 0. That's no good. So I can't borrow from the tens place value. I need to borrow from the hundreds place value. It's another 500, by the way. So what I'm going to do is I'm going to take the 500. I'll kind of show the work over here. 500. I'm going to split it up into 4 of the hundreds. So now the 5 is a 4 for the hundreds place value. And that'd be 9 tens. So now instead of a 0 in the tens place value, I have a 9. And again, this is where the borrowing part comes from. These 10 ones here, the end of the 500, they go into the tens place value. But with the 2 that were already there, now it makes 12. So I'm going to focus on the one. I'm going to go back to the ones place value. Focus there. 12 minus 6, 2 fingers up, 6 fingers down, 6. That's the ones place value. Now the tens place value, 9 minus 8, 9 fingers up, 8 fingers down, 1. That's how many fingers I had up. Now the next place value, the hundreds. Well, see, here we have it again. All right, so in the hundreds place value, 4 minus 7, 7's too big. I got to look in the next place value. Oh, there it is again. See that? It can even happen twice in one problem. I got a 0 in the thousands place value, so I got to look in the 10,000s place value. So I'm going to show the work down here. Again, all this work that I'm showing here on the bottom, like this stuff, none of this stuff would be required, even on a written test. For the most part, students just like to show it like this. But I'm showing all the work here so that you understand where the borrowing is coming from, right? Because if you can understand that, there's no amount of borrowing that you cannot do. So I would look at that. It's really 60,000, right? So it's 60,000. But I need to borrow into the hundreds. So then I would say, okay, the 60,000 now is 50,000, right? So I decreased it by 1, which gives me 10,000 to work with. But the 5, I think I said 5,000. That's 50,000 right there, okay? The 50,000 now takes the place of the 6, right? Because I'm taking 10 away from it and putting it in other place values. Well, that would also be increase the thousands place value by 9, right? So now instead of a 0 there, I would have 9 of those thousands. But in addition to that, there's another 1,000, right? So all of this stuff right here makes 60,000, which is what we want. And yeah, there's the other 10,000 right there. We got the 9 in the 10,000s place value. Now I've got another 1 to carry over into the hundreds place value, right? So this blue one right here in the hundreds place value represents this 1,000 right here. Now with the other 400, it's really 1,400, of course, but we're going to subtract 700 from that. So let's go back to focusing on one place value at a time. And while I didn't use 2 boxes on this one, it is common for students to use 2 boxes. If you had 2 pieces of paper just to focus on one place value at a time, okay? So that's 14 minus 7. So 4 fingers up, 7 fingers down. I got 7 fingers up. So that's 14 minus 7 is 7. Now let's look at the next place value. Again, it's not 0 minus 5 anymore. It's 9 minus 5. 9 fingers up, 5 fingers down, 4 fingers up. So that's a result of 4 there. in the thousands place value. And in the 10,000s place value, it's just that 5 right there, which we're going to drop. So that's a 5 right there. So our final result here, the difference between those two values. What values was it again? It's 60,502 minus 5,786 is 54,716. Now, I kind of use different colors here. I hope that's not a problem. We could always just write over that as 54,716, however you like it. 96,003 minus 1,324. I'd like you guys to try this one, and I know you may not feel comfortable doing this yet, but do try it. And what I'd like you to do is, if you don't feel like you know fully how to do it, still try it and make mistakes, okay? What we're going to do is I'm going to go over it afterwards, and then if you did make mistakes, then hopefully you can learn from those mistakes. That's a good part of the learning process, if you can learn from it, okay? So as you make mistakes, and if you don't understand the mistakes you've made, just let us know what you did, and then hopefully we can help you out, okay? But take a minute, try this problem out, and then we'll go over it, okay? 1 minute, go. All right, I hope that was long enough. If it wasn't and you're still working, do finish, all right? And then check your work with what we get. And again, if you make mistakes, try to learn as you can from them, but if you have questions, please let us know, all right? So I've already set this one up, 96,003 minus 1,324. So I would focus on one place value at a time. Let's start with the ones place value, which is 3 minus 4. And yeah, this one is set up just nice because we're going to have to borrow with the zeros thing, right? So I'd have to look at the tens. Oh, there's no tens. Go to the hundreds. Nope, none there either. Boom, in the thousands, I can borrow from that. And I'm going to show this again. It's kind of like what we did up here with the 60,000, but now it's just 6,000. So I'm going to break it up into 5,000. Right, so now in the thousands place value, I'd have a 5 there. It's also another 900, which is going to be in the hundreds place value. And another 90, which is in the tens place value. And then I kind of ran out of space there, but there's another 10, which is going to go into the ones place value. So I got 13 in the ones place value with the minus 4. I can do that. But remember, this is 5,990, and then this other 10, that's what made that 6,000 right there. So even though I've changed the way that the number looked, I have not changed its value, which in mathematics is crucial. If you're able to do and acquire that skill, change the way values look without changing its actual value, you can go places in math, okay? So I'm looking at this as 13 minus 4. So 13 minus 4, 3 fingers up, 4 fingers down. I got 9 fingers up. Boom. That's in the ones place value. Let's go to the tens place value. 9 minus 2, 9 fingers up, 2 fingers down, 7 fingers up still. I'll put in another box here so we can focus on the place values individually. Hundreds place value, 9 minus 3, 9 fingers up, 3 fingers down. I got 6. Now the thousands place value, 5 minus 1, 5 fingers up, 1 finger down is 4. And now the 10,000s place value, just a 9. So I'm just going to drop it as a 9. Now, again, I'm putting the arrow there just so I know I'm dropping the 9 directly. It's not required that you do that. All right, so it looks like we have our result here. Move the boxes out of the way. And that would be our difference between 96,003 and 1,324. It is 94,679. So yeah, 9,330, it's a 0 in the ones place value. I'll try to fix that 0. Kind of looked like a jacked up 6. And then we're subtracting 8,728. So again, just identifying each of the place values. They're all lined up. So 8 in the thousands, 7 in the hundreds, 2 in the tens, 8 in the ones, and 9,330, 9 in the thousands, 3 in the hundreds, 3 in the tens as well, but 0 in the ones. So yeah, this creates another unique scenario with subtracting with zeros, right? It's not that we're borrowing from the 0. It's that we're borrowing with the 0, okay? So the 0 minus 10, yeah, we can't take away 8. I think I said 10, I meant 8. 0 minus 8, that's no good, okay? It's too much. So I need to increase the value of that 0. And again, if we look at by place values, it means I need to make this a 10. So I look to the 10s, I see the 3, which is 30, right? So it's really 30, but I'm going to change it into 20 and 10. So the 3, that becomes a 2, that's from the 20 and the 10's place value there. And then these other 10 are going to be added to the 1's place value. So I got 10 minus 8, 10 fingers up, 8 fingers down, that's 2 fingers up. That's the 1's place value. I should have made the boxes there, I apologize. There we go. Now the 10's place value, I'll make another one here. Again, that's just to help us focus on each place value one at a time. Well, that's 2 minus 2, which is, well, 2 fingers up, 2 fingers down is 0. So that's the 10's place value. In the 100's place value, I got 3 minus 7. Well, the 3 is not big enough to take 7 away, so I got to borrow from my 1,000's place value. So the 9,000 is going to become 8,000 here. Is it 8? And I'm going to give one of those thousands into the 100's place value as 13 now, because I combine it with the 300's. So let's go back to the 100's place value here. 13 minus 7, 3 fingers up, 7 fingers down, I get 6. And then our final place value, 8 minus 8 there, right? Because the 9 is no longer there. I crossed it out. That's a 0. So let's look at the full difference on here, okay? That's a 0602. That's 602, which means the 0,000s, I don't really need to identify that or hold that place value with any digit like 0 because it's non-existent. Nor is it significant with any of the other place values. So 602 would be our difference on that one. Let me box that in. There we go. All right, then this last example, 81 minus 76. So 8 in the 10's position, 1 in the 1's, 76, 7 in the 10's, 6 in the 1's. Let's go and subtract these place value by place value. I'll start with the 1's. And yeah, again, we got 1 minus 6. It's not big enough. So I need to look into the 10's place value real quick and borrow one of the 10's from the 8. So I'm going to tack it on to the 1's. And since I borrowed it, it's going to decrease those 8 10's, 1 10. So now it's a 7 10's there. So we'll go back to the 1's. 11 minus 6, 1 finger up, 6 fingers down. I got 5 fingers there. And now the 10's place value, 7 minus 7. So 7 fingers up, 7 fingers down is 0. It's good. And what is our final difference here? We got 0, 5. And again, the 0 in the 10's place value, it's just holding that place value. We don't really need it to, though. If I don't have anything there, you can just make it so that it shows nothing there also. So our final difference is 5. So again, just going back to kind of the basis of this, all right, is 81 minus 76 is 5, or the difference between 81 and 76 is 5, or the distance between 81 and 76 is 5. I don't know if any of that vocabulary helps you out, but I kind of hope it does. You know, that's why I did it. So combining estimation with subtraction. Yeah, we're just rounding these. So remember, when it says to estimate with rounding, and then, you know, it doesn't really matter what operation we're using, but subtraction here. So you're going to do the estimation first, or the rounding first, and then you're going to do the subtraction, okay? So for this problem, this example that we have right here, 8,370 minus 5,886. And I know you probably feel comfortable doing that just without the rounding right now, okay? But let's say that this one required front-end rounding, just like it says there, which again means we're rounding to the front end. The digit or the place value farthest to the left, which for the 8,370 is the 8. So I look immediately to its right, and the 100's place value is a 3. Now 3 is less than 5, which means the 8 in the 1,000's place value will stay in 8, but all the other 3 place values are going to be zeros. So that's 1, 2, 3 zeros there. So 8,370, front end rounded is 8,000. Now the 5,886, the 5 in the thousands, I look immediately to its right in the hundreds place value, and that's an 8. So I need to add 1 to the 5 to make that 6 in the thousands place value. Those other 3 place values in the hundreds, tens, and ones place values become zeros. And we're just subtracting this, right? So I'll show the subtraction. And I'm not even worried about doing this problem right here anymore. I'm focused on just the rounding problem. Well, what's nice about this is it created lots of zeros for us to subtract. And 0 minus 0 is just 0. That's nice. Same with this, 0 minus 0. 0 minus 0 is still 0. But then 8 minus 6, 8 fingers up, 6 fingers down, boom, 2 fingers up. So our final result after the rounding is 2,000. And that's with front-end rounding. The other thing, remember about front-end rounding is that you're not always rounding to the same place value between these two numbers. So, like if the 5 weren't there, then we would have to have rounded to the 8 in the hundreds place value, okay, which would have been 900 in this case. But that may change where these numbers are, so it may still require some borrowing with zeros with front-end rounding, or well, I guess it could create a situation with other rounding as well. We'll see. On this example, we're going to round to the tens. So we're going to round the two numbers, then we're going to find the difference, 2,457 minus 521. So again, I'm going to write it out as it is, 2,457 minus 521. You don't have to do it like this, but I'd like to see it as it's written, so I know where the rounded numbers will be. So the 2,457, that's the top number. We're rounding to the nearest 10, so I see the 5 in the tens place value. Immediately to its right is the 7 in the ones place value, which means 7 is 5 or more, so I need to add 1 to the 5, making it a 6 in the tens place value. The 7 in the ones place value now becomes a 0, and the values, I should have separated that 0 a little bit more. There we go. And the values to the left of the tens place value were unaffected by the rounding. So that's a 2 in the thousands, 4 in the hundreds place value there. We are going to subtract, but I need to round the 521 to the tens place value. So that's a 2 in the tens place value. Immediately to its right is a 1, which means the 2 in the tens place value will stay a 2. And the ones place value to its right becomes a 0, and the 5 to its left in the hundreds place value stays a 5. And this is our new rounded calculation, 2,460 minus 520, and we'll just work with each place value from right to left. And yeah, that first one isn't too bad. 0 minus 0 is still 0. We'll move it to the right here. Focus on the tens place value. That's 6 minus 2. 6 fingers up, 2 fingers down. I get 4. Now the hundreds place value, 4 minus 5. Well, that 4 is not big enough, so I need to borrow from the thousands place value, that 2. One of the thousands will go to the hundreds place value, and the other thousands will stay. So that's good. We got that down. Let's go back to the hundreds place value. 14 minus 5. 4 fingers up, 5 fingers down, leaves me with 9 fingers up there. And now the thousands place value, yeah, the 1 is just going to drop as a 1. So that difference becomes 1,940. After rounding to the tens place value from 2,457 minus 521. All right. So let's do this problem. I probably should have given myself more space between the tens and ones. That's okay. So again, I'm going to focus on one place value at a time, starting with the ones place value. So 9 minus 6, 9 fingers up, 6 fingers down. I get 3 fingers up there. So now I'm in the tens place value there. 7 minus 5, this one's doable. So 7 fingers up, 5 fingers down. I got 2 fingers up still. Now, we haven't had any borrowing. We are going to have some, though, right here in the hundreds place value. It's 2 minus 8, but the 8 is too big to take away from the 2. So I need to borrow from the thousands place value here. It's a 6 in the thousands. I'm going to take one of those and put it into the hundreds place value, which means that the 6 is now reduced to 5 thousands. So focusing again on the hundreds place value, I got 12 minus 8. So 2 fingers up, 8 fingers down. I got 4 fingers up there. So that's the hundreds place value. Now the thousands place value. 5 minus 2 is doable. 5 fingers up, 2 fingers down. I got 3 fingers there. That one was nice. I only had to use one hand. Same with this one, I guess. 4 fingers up, 3 fingers down. Boom, I got 1 finger up. So this result, 13,402. That's what we get when we take 46,279 minus 32,856. All right, let's say that this one wanted to be front-end rounded, okay? So we're going to front-end round both of them, right? So I'd say, look at the 4 in the 10,000s place value. I mean, we did find the actual number, but we're just front-end rounding now. To its right, that was a 6. Okay, I'm looking at this before we had subtracted. So it's 46,279. The 6 in the thousands place value, it's 5 or more, which means I need to add 1 to the 10,000s place value. 4 plus 1 is 5, and then all the place values to the right become zeros. And there's 4 place values to the right of the 10,000s place value. Those are all zeros now. Now we are going to subtract here, but it's 32,856 rounded, front end rounded, I should say. And so, yeah, you see the 3 in the front end, that's the 10,000s place value. Just to its right is a 2. Since it's a 2, the 3 is going to stay a 3 in the 10,000s place value. But the other place values will become zeros. So that's in the thousands, hundreds, tens, and ones. So again, the subtraction, the nice thing about this, especially front-end rounding, when they have the same place values, is you get a bunch of 0 minus zeros, okay? Which is just 0. So that's 4 zeros there, 5 minus 3, which is 2. So that ends up, front-end rounding is 20,000, which I know is nowhere near 13,423, but it doesn't matter with the front-end rounding. We just did it like it told us to, okay?